This video, we're going to look at the Chatelier'S principle in chemistry. We're going to look at the effects of temperature, pressure, and concentration of reactants or products on the Chatelier'S principle. So let's begin by stating the principle. So the Chatelier'S principle states that when a system in equilibrium is affected by some factors such as temperature, pressure, or concentration of reactants or products, the system will adjust itself in order to cancel or annul the effect of change. So let's begin with the concentration factor. Let's say we are given this decomposition reaction, calcium, right, carbonate 4, decompose to give calcium oxide, alright, plus carbon 4 oxide. Alright, now note that we use this double-headed arrow to indicate that the reaction is in equilibrium. Okay, in this kind of reaction, for concentration factor, increase in reactant concentration will cause the equilibrium position to shift from the left to the right, favoring the forward reaction, whereas decrease in reactant concentration will cause the equilibrium position to shift from the right to the left, favoring the backward reaction. In other way around, increase in product concentration will cause the equilibrium position to shift from the right to the left, favoring the backward reaction, whereas decrease in product concentration will cause the equilibrium position to shift from the left to the right, favoring the forward reaction. Alright, so that's how the factor of concentration of reactants or products will affect the equilibrium position. Okay, let's look at the next factor, pressure. Let's say we have this reaction, nitrogen gas reacts with hydrogen gas, 3 moles of hydrogen gas to yield 2 moles of ammonia gas. Alright, so now for pressure to affect the equilibrium reaction, the reactants and the products have to be in gaseous state. As in this kind of example, we have nitrogen is a gas, hydrogen is a gas, and ammonia is also a gas, so pressure can affect it. Alright, so take note of that. The reactant and products have to be in gaseous state for pressure to apply. And you know, in Boyle's law, increase in pressure implies decrease in volume. Alright, so in this situation, increase in pressure here will cause the equilibrium position to shift to the side with fewer moles of gases. So here we have 2 moles of gases. So here we have 4. This 3 plus, there is 1 behind this nitrogen gas, but it's invincible. So 3 plus the 1 here is 4. So that's why increase in pressure will cause the equilibrium position to shift to this right side of the equation, favoring the forward reaction, because this side is the side that has fewer moles of gases, whereas decrease in pressure will cause the equilibrium position to shift to the side with more moles of gases. Alright, so decrease in pressure will cause the equilibrium position to shift to the side with more moles of gases. Note again that when the mole of the gaseous reactants is equal to that of the product, change in pressure and volume will not affect the reaction. So at the beginning, we are having this 4 moles of gases here, also having 4 moles of gases here. Okay, this 4 here is for the product, this 4 here is for the reactants. Alright, so we are having this situation where the moles of the gaseous reactant, the mole of the gaseous reactant is equal to the mole of the product. Alright, so change in pressure and volume won't affect the equilibrium position. Alright, so take note of this. And let's look at the effect of temperature on equilibrium position. Now for temperature, when you talk about temperature, talking about heat. It's either heat is being evolved, they are released to the environment, or heat is absorbed from the environment or gotten from the environment. And when heat is released, we call it endothermic reaction. When heat is absorbed, we call it endothermic reaction. So in an endothermic reaction, let's say we have nitrogen gas plus oxygen gas react to give 2 moles of nitrogen oxide, and the enthalpy change is positive, indicating that is endothermic reaction. Heat is absorbed from the environment, kilojoule per mole. Alright, so when the reaction is endothermic, alright, now for the effect of temperature, increase in temperature will cause the equilibrium position to shift from the left to the right, favoring the forward reaction, whereas decrease in temperature will cause the equilibrium position to shift from the right to the left, favoring the backward reaction. Okay, now for exothermic reaction, let's say we have this reaction, 2 moles of sulfur 4-xy plus oxygen. We had to give 2 moles of sulfur trioxide, and we have enthalpy change to be minus 395.7 kilojoule per mole, indicating that it's exothermic reaction. So how the effect of temperature will affect is that increase in temperature will cause the equilibrium position to shift from the right to the left, favoring the backward reaction, whereas decrease in temperature will cause the equilibrium position to shift from the left to the right, favoring the forward reaction. Alright, so it's the reverse of endothermic reaction, how the temperature effect will apply. Alright, so guys, this is basically what the Chatelier'S principle is trying to explain or talk about, how the effect of temperature, pressure, and concentration of reactor products will affect equilibrium position in an equilibrium reaction. Alright, so with this we have come to the end of the class. Hope you learned something interesting. If you are new to the channel, sure you hit the subscribe button to subscribe for more videos. So like, share, and comment on this video, tell me how you feel, what you have learned. If you seem to have any specific questions, feel free to leave your question in the comment section below, and I'll be sure to give a response. That's it for this class, guys. Thanks for watching.